Hello, today we're going to be working on section 2.4. It's a topic about symmetry. So let's start with problem number 1 in section 2.4. So this is just, a little bit of it is just visual. We're looking for symmetry about an axis. In this case it says, determine visually whether the graph is symmetric with respect to the x-axis, y-axis, or the origin. And so this is something you can kind of eyeball. So there's the mirror, and you want to make sure that a point that's over here is also in the mirror reflection across. So this is symmetric about the y-axis because there are points on both sides of the axis. They have the same y value. So like, if you imagine this x value, let's say that value was 5. At -5, they would have the same value of, maybe that's -1, and so this would be +5, -1. So they both have the same y values for a x value that's the negative of that. All right, let's do another one. Now, determine visually whether the graph is symmetric with respect to the x-axis, y-axis, or the origin. This one has a different kind of symmetry. This symmetry is about the x-axis. This is where the mirror is located. And the reflection, so this point gets reflected down there in the mirror. Now, it's not symmetric about the y-axis. The origin we'll talk about here in just a second. But this one, this definitely is symmetric. It's about the x-axis. And the x-axis only. This is the x-axis. Symmetric about the x-axis. Answer is yes. It is not symmetric about the y-axis. And it is not symmetric about the origin. We'll talk a little bit more about that. So in this situation, let me count that point there. 1, 2, 3, 4, 5, 6, 7. That point there is 7, 10. With x-axis symmetry, the x-coordinate is the same, and the y-coordinate is the negative value. So if you could look up at the previous one, the x-coordinate was the one that was different by a negative, and then the y-coordinate was the same. Here, the x-coordinate is the same, and the y-coordinate is the negative of the other. All right. This one is not symmetric with respect to any of them. We haven't talked about the origin yet, but clearly this point is not in the mirror, and similarly, this point is not in the mirror. So definitely not x-axis, y-axis. The origin, we'd look for a point over, so like this point would appear in the mirror over here. But we'll do an example like that here in just a second. So determine the symmetries of the graph given. Now this one requires getting out your calculator. So I highly recommend graphing these things. Now if you already know what the graph looks like, then it makes it a lot easier. But there is a test for symmetry, and we'll show you that. But that's just based off of the graph is what this says. Now you got to know where the absolute value is. It's actually in the math menu under num. Not a lot of people will know where that is. So you hit math, and then you move over to the num menu. Absolute value is the first one. So absolute value of x, close the absolute value, subtract 3, graph it on a standard window zoom, and there you have it. Now this, let me copy this in here, paste, and make it a little bigger. In fact, let me make the whole screen a little bit bigger. All right. So determine where the symmetries, if any, of the graph of the given relation. Relation is just a fancy word for anything that has an input and an output. Functions are a special relation where each input gives it a unique output for that input. It only gives out one output, a definitive answer. So the word relation is just being a little less picky about that. And so this definitely has symmetry about the y-axis. It is not symmetric about the x-axis because this point does not have a mirror point, and it's not symmetric about the origin. That same point does not have a origin symmetry either. So it is symmetric only about the y-axis. This has none of them, and we won't go on and on about it. Shown on the right is the graph of 7y equals 4x plus 7. Now, they're trying to be a little tricky there by putting that 7y. This is the same thing as y equals 4/7 x plus 1, and you could graph that function. This is a little bit more relation notation, where x and y don't have to be expressed in terms of x being the independent variable of y. Let's do one more here, and then we'll call it good on this video. So this graph is not symmetric about the y-axis, because if it was symmetric about the y-axis, this point would show up in the mirror on the other side, and it's not there. And it's not symmetric about the x-axis either. That point would show up in the mirror down here, and it's not there. That'd be x-axis symmetry, and we just don't have it. Not x-axis symmetry, and it's not y-axis either. But it is origin symmetric. Now, what do we mean by origin symmetric? Let me show you this point here. So this is 1, 4. Origin symmetric means you negate both the x and the y coordinate, and you end up at a point on the graph, -1, -4. If you negate both of them are negated, then you end up at a point on the graph. That is origin symmetric. People say it's reflected through the origin. Let's pick out another one with integer coordinates. That point right there is 4, 1. And if you look at through the origin, you end up here at -4, -1. So we say this is origin symmetric. It's not the other two, just origin symmetric. Hey, thanks for watching.